Okey, Assalamualaikum warahmatullahi wabarakatuh. Seperti dijanjikan, kita pergi ke bahagian tutorial, fokus kepada chapter transformer. Okey, sebelum tu kita akan go through important formula. Okey, so sebelum ni kita telah pun belajar apa itu ratio factor, iaitu A. Okey, iaitu nilai ni bersamaan dengan Y turn, the primary turn bahagi dengan secondary turn. Okay, and also the primary voltage bahagi dengan secondary voltage ataupun bersama dengan E1 over E2. Okay, walaupun bagaimanapun for ideal transformer, E1 is equal to V1 and E2 is equal to V2. Dan juga sama dengan I2 iaitu secondary current bahagi dengan primary current. Okay, so make sure that this is 2 dekat atas, 1 kat bawah. Okay, so hanya I saja yang berbeza dari segi rumus. Okay, so selain tu kita tahu apabila A itu bersama dengan 1, so ianya menunjukkan adalah isolation transformer. Manakala bila rendah daripada 1, ianya adalah step up transformer. Dan juga jika lebih daripada 1 adalah step down transformer. Okay, so ini adalah gambar rajah arm bagi transformer. Okay, dan juga kedudukan current, voltage dan juga turn. Okay, so sebelum ni kita ada belajar the formula berkaitan E dan juga flux. Okay, so ini adalah persamaannya. Okay, jika ambil bahagian secondary, so make sure turn yang ditunjukkan di sini juga menggunakan nilai secondary. Okay, jika primary, so you guna primary. Frekuensi sepatutnya sama dua-dua dan juga flux, muncul fluxnya juga adalah sama bagi kedua-dua rumus. Okay, so for ideal, sebelum ni yang saya beritahu, E1 is equal to V1, E2 equal to V2. Okay, so persamaan yang atas ni, so yang ni you tak tahu, kalau you nampak E1 itu, so you boleh guna terus V1 dan juga V2 sebab you consider sebagai ideal transformer. Okay, and the last, kita ada belajar apa itu efficiency. Okay, efficiency ni maksudnya adalah P out bahagi P in. Okay, yang mana kalau rumus asalnya, rumus yang kalau saya drop down iaitu P out bahagi dengan P out plus P copper plus P copper and P core plus P copper. Okay, PC ni P core plus PCU is P copper. Okay, so rumusnya adalah yang ni. So sebelum ni chapter 1 dah belajar P sama dengan IV cos theta. Okay, so since P out ni adalah di secondary, so kita akan ambil nilai V2. Okay, V2, I2 and cos theta 2. Okay, so yang ni untuk V, ni sama P out yang atas, so dia follow saja, cuma ditambah dengan P core plus P copper. P copper iaitu I square R equivalent. Okay, so yang ni jangan risau, kita akan buat satu contoh berkaitan dengan yang ni. So actually you tak perlu terlalu detail sangat. Okay, so kebiasaannya soalan untuk civil engineering tak terlalu detail lah. Okay, so yang ni kita akan go through, ada 2 soalan berkaitan dengan efficiency yang kita akan go through. Okay, so next, ini adalah example. Okay, so actually kita dah dalam slide dah pun buat, tapi saya prefer untuk buat balik. Okay, so a transformer coil has possessed 4,000 turn. Okay, and link an AC flux having a peak value of 2 milliweber. If the frequency is 60 Hz, calculate the voltage E. Okay, so saya tulis balik data-data yang telah diperolehi, iaitu N is equal to N is equal to 4,000 turn. Flux M is equal to 2 milliweber, and then frequency is equal to 60 Hz. Okay, so kita balik pada persamaan asal yang seperti pada important formula, E is equal to 4.44. Okay, and flux M and frequency. Okay, so sekarang ni you nak cari E, so just drop, masukkan nilai N iaitu 4,000 and then 2 milli and then 60. Okay, sorry, tulisan tak cantik sikit. Okay. So, di sini kita akan kira. Okay, so pengiraan dia senang. 4.44 times 4,000 times 2 milli times 60 Hz. Okay, so jawapan dia akan jadi 2131.2 volt. Okay, so ini adalah jawapannya. Okay, so soalan ni kategori simple lah, tak susah. Okay, so kita go pada example tu. 200 kVA, okay, dengan transformer ratio-nya adalah 6600 bahagi 400, and then the frequency is 50 Hz with single phase transformer, has a 80 turns on secondary. Okay, so ini adalah maklumat yang penting untuk sebuah transformer. Okay, so calculate the approximate value of the primary and secondary current. So soalan A, okay, so soalan dia adalah I1 is primary current, and also the I2 is secondary current. Okay, so based on this calculations, kita tahu ini adalah V1, ini adalah V2, ini adalah frekuensi, ini adalah N2. Okay, and ini adalah S. Okay, S, transformer, apparent power untuk transformer. Okay, so saya tulis dulu kat sini. V1 is equal 6600 volt. Okay, V2 is equal to 400 volt. N2 is equal to 80. Okay, so the S is equal to 200 kVA. Okay, so cara untuk dapat I1, okay, so kita balik pada rumus S. Okay, so kita dah belajar pada chapter 1, S equal to IV. Okay, so that's why unit dia pun volt M, VA. Okay, so untuk dapatkan nilai I, so S akan bahagikan dengan I. S akan bahagikan dengan V. V. So because S is equal to IV, so I sama dengan, okay, so here kalau I1 sama dengan 200 kVA bahagikan dengan, since kita nak cari I primary, so kita akan bahagikan dengan voltage primary 6600. Okay, ni kena tekan calculator. K bagi 6600 sama dengan, so jawapan dia adalah 30.333 M. Okay, so ini jawapan dia. Okay, so kita go pada I2. I2 pun sama, S bahagi V, cuma yang atas tadi ni V1, yang ni kita kena bagi V2. So 200K bahagi 400. Okay, jadi 200K, jangan lambat pula kan. So jawapannya adalah 500 M. Okay, so kita dah dapat untuk soalan A, kita dapat I1 dan juga I2. Okay, so kita guna S dan juga ratio V1 dan juga V2. Okay, so soalan B, so kita terus pada soalan B. Okay, B. So the approximate number of primary turn. So soalan dia nak tahu apa itu nilai N1. So kita telah diberi N2 di sini. Okay, dah ada N2 kat atas ni dah ada N2. Okay, so kita nak N1. Okay, so kita balik pada perumahan asal iaitu ratio, turn ratio, ratio factor. A sama dengan V1 over V2 is equal to N1 over N2. Okay. Dan juga adalah I2 over I1 lah. Tapi untuk yang ni kita just fokus, kita nak carikan turn pada primary. Okay. Kita tahu V1, V2 dan juga N2. So daripada sini kita tahu N1 is equal to V1 over V2 times N2. Okay. So just masukkan nilai je lah. 600 over 400 times N2 is 80. Okay. Okay, so the value is 131320. Okay, so this is the answer. Okay, for B. Okay. So next, C is a maximum value of the flux. Okay, so go through sini juga. C. So silap pula tekan. Okay. So this is the maximum value of flux. Okay, flux M. Kat sini kita nak cari flux M. Okay. So saya bawa ke page sebelah dulu. Okay. So kita tulis balik apa nilai yang telah kita find out sebelum ni. Okay. Okay. Kita tahu V1 sama dengan 6600, V2 is equal to 400, and 2 equal to 80 turns, and also S is equal to 200 kVA. Okay, ni volt. Okay. So the question is kita nak carikan untuk soalan C, kita nak cari flux M. Okay. So kita rewrite balik equation yang berkaitan dengan flux M, hanya ada satu saja lah. E sama dengan 4.44 N flux M F. Okay. So E ni depend, kalau you guna E1, N pun akan juga jadi N1. Okay. Jika you guna E2, so N ni you akan guna N2. Okay. So here you boleh bagi flux M is equal to E1 over 4.44 N1 F. Okay. Okay. So here kita tahu E1 sama dengan V1 untuk ideal transformer. So it's a 6600 divide with, so yang ni frequency is equal to 50 Hz. Okay. Okay. And then 4.44 N1 is equal to yang telah pun kita dapat tadi 1320. Okay. Dan juga frekuensi adalah 50 Hz. So based on calculator, so you kena press calculator. Okay, so the answer is 22.52 milliweber. Okay, so ini jawapan dia lah. Okay. So kalau ikut ni adalah, sorry. Okay. So ni kita balik pada soalan tadi, example tu. So first kita cari primary current, and then kemudian kita cari secondary current. Okay. So the term is still the same. Okay. You ada tu S over V1 and S over V2. So you akan dapat this value. Manakala untuk nilai ratio turn pada primary turn, so you guna balik ratio factor here. Is equal V1 over V2 and N1 over N2. So you can get the answer for N1. Okay. And then base here, so the value is, okay, ni saya tulis balik. Okay, so untuk dapatkan flux, so you guna balik rumus ini, okay, di mana E1 is equal to V1. So you rewrite balik this equation and then you masukkan nilai and then you dapat 22.52 mili. Okay, next for example 3. Okay, an ideal transformer having 90 turns on the primary and 2250 turns on the secondary is connected to 200 volt and 50 hertz source. Okay, so the load across the secondary draw a 2 amp at the power factor of 80% lagging. Okay, so the question is the effective value of the primary current. Okay, first of all, I will write down all the given value. For example, N1 is equal to 90, N2 is equal to 2250. Okay, since it's a 200 volt 50 hertz source, okay, so the frequency is 50 hertz. Okay, and then the V1, okay, since it said that it's a source, so it's a V1 is equal to 200 volt. And the load across the secondary, I secondary is equal to 2 amp. Okay, so the first question is A, the effective value of the primary current. Okay, so by using the ratio factor, so we know that N1 over N2 is equal to I2 over I1. Okay, so here you can find the value of I1. Okay, by rewrite back this equation, I1 is equal to I2 N2 over N1. Okay, so just getting back the value. 2 N2 is 2250 over 90. So the answer is 2250 times 2 divided with 90. So the answer is 50 amp. Okay, so you get the answer for the primary current. Okay, next we go to B, the instantaneous current in the primary when the instantaneous current in the secondary is 100 milliamp. Okay, so I think we still use the similar factor, which is ratio factor is equal to N1 over N2 equal to I1 I2 over I1. Okay, but we have to know that 100 milliamp is a I2. Okay, so using the similar formula, okay, so I1 is equal to I2 N2 over N1. So we key in the formula, so it's 100 milli into 2250 over 90. So you get the value is 2.5 amp. So you get the value is 2.5 amp. Okay, so this is the answer. Okay, so this is the answer for B. Okay, so next, the peak flux link by the secondary winding. Okay, so let's rewrite back this equation. Okay, I just put back the value here. Okay, so here is it's not V1, it's the N1. This is equal to 90 turn. N2 is equal to 2250. V1 is 200 volt. And I2 is 2 amp. Okay, it's 2 amp. Okay, so we are going to answer for C. We need to know what is the flux. Okay, we rewrite back the equation. The simplest equation is 4.44 and flux M F. Okay, So the value is given is only E2, E1, okay, because we already have a V1 and also N1. Okay, if you want to use the V2 and N2 is still okay, but the value of flux will be the same. Okay, so here we are going to find the flux is equal to E1 over 4.44 N1 times with the frequency. So the E1 is 200 volt divided with 4.44, and the N1 is 90. The frequency is 50. Okay. Okay, let me press the calculator first. And the answer is 10 milliweber. Okay, 10 milliweber. Okay, so get the answer. Okay, so that's the question number 3. Okay, so this is the for A, to find the effective value of the primary current, which is I1, we get 50 amp. For B, we get the instantaneous current for primary when the secondary is 100 milliamp, so we get 2.5 amp here. Okay, next, to get the flux link by the secondary windings, the peak flux. Okay, so the flux is flux M here, and then this is the formula. And when you key in 200 over 4.44 times 90 times 50, you get 10 milliweber. Okay, don't forget the units. The units is Weber. Okay, so next we go to next question. Okay, this is the final year question, the past final year question. Okay, this is very simple question. For example, you have a 100 kVA transformer with 4. Okay, this is S. Okay, this is V1, this is V2, and this is frequency 100 secondary turn. So this is N2. Okay. Okay, so the first question is to determine the primary current I1. Okay, I1. So what is the value of I1? Okay, so based on this, you can get the value of I1 by using the formula of S. Okay, the apparent power. So we know that S is equal to VI with the unit of VA. Okay, the units of apparent power is VA. So it's stated here. Okay, so it's given there is 100 kVA. Okay, so using this we can S over V1. Okay, so 100k over 4,500. Okay, you get 100k. Let me press the calculator first. It's 22.22 amp. Okay, 22.22 amp. So this is the answer. The second question is to get the secondary current. So what is the secondary current? You have a two choice, whether you still use S over V1, S over V2, or you can use the ratio factor. Okay, which is A. This is equal to N1. V1 over V2 is equal to I2 over I1. Okay, the answer should be same. Okay, so I give an example here. So we use this formula, 250, so it's equal to, let me press the calculator first, is 400 amp. Okay, so you get the answer. And if you want the next, the number of primary turn, okay, you need to find what is N1. Okay, N1. Okay, so you can use the ratio factor, which is V1 over V2 is equal to N1 over N2. So you are going to find the N1. So you can rewrite back this equation, which is N1 is equal to V1 over V2 times N2. Okay, so 4,500 over 250 times N2 is given 100. Okay, so you get the value is Let me press the calculator first. Times 100 is 1,800. Okay, it's 1,800. Okay, so you get the answer. Okay, it's a 1,800. Okay, so the answer is 1,800, and 1 is equal to 1,800. Okay, so this is for question. Okay, we have finished to answer all 3 questions. Okay, next we go to the next question, which is a high voltage transformer having rating voltage at 480 volt and 400 winding turn. Okay, determine number of turn required in low side if the rating voltage is 120 volt. Okay, so the high voltage transformer having rating voltage of 400 volt. This means V1 is equal to 480 volt, and N1 is equal to 400 turn. Okay, determine the turn required in low voltage. Okay, so the V2 is equal to 120 volt. Okay, so based on this question, I think if you read this question, it's quite confusing. Okay, but you can, by using the ratio factor, so it's very simple. V1 over V2 and 1 over N2. So the number of turn required in low voltage, N1 is high voltage, okay, N2 is a low voltage. Okay, for these cases. Okay, so you can find the number of N2, okay, is equal to V1 over V2 times N1. Okay, so you can rewrite the equation. So V1 is 480 over 120 and times 400. Okay, so let me press the calculator. 120 times 400. So the N2 is 1,600. Okay, so this is the answer. Okay, so if you read the question, it's very confusing, but actually the answer is very simple. Just using the simple formula from a ratio factor. Okay, so next, one phase transformer 200 kVA. Okay, so we have here the kVA is S, it's apparent power. This is V1, this is V2, 11 kV and also 400 volt, and the frequency is 50 Hz and the 100 turn on the primary side, which is this is N1. Okay, N1. Assuming the transformer is ideal, at the rated value, calculated the value of primary and secondary current and the number of turn in the secondary, assuming a load power factor of unity. That means the power factor is equal to 1. Okay, so the question is require us to find the primary current, which is I1. So we need to find the I1 and also the secondary current, and the last is to find the number of turn in secondary, which is N2. Okay, so let's start with the I1. So I think this is similar with the previous one. So the I1 is equal to, when you are given the S 200 kVA, I think the similar process, S equal to VI. So the I1 is equal to S over V1. Okay, 200K over 11K. Okay, so the value is 18.18 amp. Okay, next for I2, so we use a similar formula. So 200K over 400. So we get 500 amp. Okay, so I think the question is quite similar from previous, but the style of question deliver is different. Okay, so next is we want to find the N2. Okay, so we know that based on the A is a ratio factor is equal to V1 over V2 is equal to N1 over N2. Okay, back to the initial equation. Okay, so N2 is equal to V1 over V2 times N1. Okay, so you get the V1 is 11k over 400, N1 is 1000. Okay, so the value is, okay, let me press the calculator first. 1000. Okay, so the value is 27,500. Okay, so since normally for low voltage they have a higher current compared to the high voltage, because the typical equation is there. Okay, for next question, so we go for this question, which is A is given the transformer which is 50 kVA. So this is S with transformer ratio 5000 stroke 500 volt, which is this is V1 and this is V2. The 50 Hz is the frequency. Okay, so it's given the, okay, this question is quite popular. Okay, so please give more perhatian kepada soalan ni. Okay, so single phase has a high voltage winding resistor which is R1 is equal to 8 ohms and R2 is equal to 0.06 ohm. Okay, and also it's given the core losses, which is PC is equal to 1000 watt. Okay, so this is a core loss. Okay, so let's go to the first question. Calculate the efficiency of the transformer when delivering its full rated output at the power factor of 0.8. Okay, so we know that for the first question, we are required to find the efficiency. So the basic formula of efficiency is P out over P in. Or we can write that as a P out over P out plus P core plus P copper. Okay, so I think I just put it at the important formula. Okay, at the second slide. Okay, so let's find out what is the P out. Okay, so the P out, okay, since the question is given that there is a power factor 0.8, okay, so you have to find the value of P out. So you are given the value of S, okay, and also you have a power factor, so you have to times with the power factor, which is 50k times 0.8, which is 40k watt. Okay, so this is P out. The PC you already been given at the question above. Okay, this is PC. And what is a PCU? Okay, so please to find the PCU, so you have to identify which one, since you have to choose whether you want to put that at the primary or secondary. Okay, so the answer should be same if you put at the secondary or primary. Okay, so for this question I choose to put the PCU at primary. Okay, PCU at primary. Actually the answer is still the same. PCU primary and secondary is still the same, but you have to be cautious with the value that you put. Okay, so PCU is I square. For example, I use the primary I1 square and R equivalent. Okay, so what is R equivalent? So for here, R equivalent is equal to, for primaries, so R1 plus, okay, A square R2. Okay, this is R1. Okay, R1 plus A square R2. Okay, so the R1 is 8 plus A square. What is the A square? Actually, is a ratio. So 5000 over 500 square R2, 0.06. Okay, so the value of R equivalent is, let me press the calculator first, square is 100, 0.06 plus 8. So it's a 14 ohm. It's a 14 ohm. Okay, so the R equivalent is 40 ohm. And what is the value of I1? So I1 is, you can use the formula there, because we have the value of S. So S over V1 is equal to 50K over 5000. So you get 10 amp. Okay, so here the PCU is 10 to the power of 2, and the value of R equivalent is 14. So you get the value of 1400 watt. Okay, so here you can find the efficiency. Okay, the C is equal to P out. So the P out is 40K divided with 40K plus 1000 plus 1400. Okay, let me calculate that. K plus 1K plus 1.4K. Okay, so you get 0.94. Okay, so this is the efficiency, 0.94. Okay, so I repeat back the equation. Okay, we have the efficiency formula here, P out over P out plus P copper plus P core, P core plus P copper. Okay, so from the equation, from the given, the equation is give S, which is apparent power. So you can find the P, okay, by multiply with the power factor. So you get the P out. Okay, so the P core is given at the equation, which is 1000 watt. And next, the important part is P copper, which is I1 square R equivalent. So the R equivalent is based on, it's given R1 and R2 here. It's given R1 and R2 here. So you have to use this formula. Okay, so 8 plus 5000 over 500 square times 0.06, which is 14 ohm. Okay, and then you have to find the I1. So because the question is not given the I1, so the I1 is S over V1, which is 10 amp. Okay, so you put all the value here, and you get the P copper is 1400 watt. Okay, so then you can calculate the efficiency. Okay, P out is 40K, divide with 40K plus 1000, which is core loss, and plus P copper 1400. So you get 0.94. Okay, so that there is no unit for efficiency, so it's just 0.94. Okay, so we go to the second question. With the same power factor, what will be the efficiency if the output drop down to 80% of the rated value? Okay, with the same power factor, that means the power factor is still 0.8. What will be the efficiency if the output drop down to 80% of the rated value? Okay, since the full rated is a S 50 kVA, and if the is dropped to 80% of the rated value, So 50k times 80%. Okay, so I will use next page. Okay, so okay, maybe I need to wait. Okay, I will put the question here so that okay. So we will focus on question number 2. Okay, with the same perfector. Okay, so we back to the original value here. Okay, so we need to find the efficiency when the output is drop 80%. Okay, okay. So the equation is still the same. P out over P out plus PC plus P copper. Okay, okay. So we are going to find the P out. Okay, since the output is dropped down to 80% of the rated value. Okay, so we say that 50k times 0.8. Okay, so this is the new value of S. Okay, and then we times with the port factor 0.8. Okay, this is port factor. Okay, don't get confused with 0.8 here and 0.8 here. 0.8 here represent 80% of the rated value, and 0.8 here is the port factor that given at the previous question. Okay, so here the answer, the P out is based on the, okay, I press the calculator, it get 32 kilowatt here. Okay, so now you have the P out and P out here. So PC previously is given 1000 watt. Okay, so the core loss nature is doesn't change. Okay, if the output is drop or increase. Okay, so it's maintained. Okay, so nanti dia kekal. Okay, 1000 watt. So it's maintained 1000 watt. Okay, so PCU, there is a different with the PCU because PCU is okay. I rewrite back the equation. Okay, I1 square with R equivalent. Okay, so the R equivalent is still same, which is previously we get the R equivalent from the first equation is 14 ohms. Okay, so the difference is only I1. Okay, how to find the I1? Okay, so the I1 is based on S, the new S. This means S over V1. Okay, but the S is dropped to 80% of the rated value. Okay, so that means 50k times 0.8. Okay, divide with 5000. Okay, so you get the value of here is 8M. Okay, okay, so now you have 8 square times 14. So you get the new is 896 watt. Okay, so this is the new P copper. Okay, 896. Okay, it's correct. Okay, so based on this value, you can find the new efficiency with the 80% after 80% of the rated value. Okay, so P out is a 32k over 32k plus 1000 plus 896. Okay, okay, 3k plus 1k plus 896. Okay, 32k divided with the answer is a 0.9. So you get the value is 0.944. Okay, so this is the answer. Okay, so actually the answer is quite similar for question 1 and number 2. Okay, but it's, the value for P copper is different, and also P out is different. Okay, 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 okay. So next question, I think this is the last question. Okay, the following are the data taken from test done on transformer rating of 3 kVA. So the 3 kVA is S here. So 240 stroke 120 volt. So this is V1 and V2. The frequency is 50 Hz. Okay. So the resistance of turn at 120 volt. So this we put that as a R2. Okay, why R2? Because 120 volt is V2. Okay. So for 240 volt is V1, so we put here is R1. Okay, and the core loss is PC. Okay, so the hysteresis and the current losses are neglected. Okay, so determine the transformer efficiency when the transformer operate in rating power. In rated power, sorry, I think this is not rating power. Rating power and unity power factor. Okay, that's mean in the rated power, which is the 3 kVA. Okay, and the power factor is 1. Okay, so since we are going to do the efficiency, so the basic formula for efficiency, P out over P in is equal to P out. Okay, the extension of that is P out plus P copper plus core loss. Okay, core loss first and then P copper. Okay, what is a P out? Okay, P out is S times power factor. Okay, here is 3K times 1, which is 3 kilowatt. Okay, you get the 3 kilowatt. The PC is given there is 28 watt. So we just take that. Okay, so how about the PCU? So the PCU, you can choose whether you want to use the primary or secondary. Okay, for example, I want square R equivalent. Okay, so the R equivalent is equal to R1 plus A square R2. Okay, so R1 is 0.055. Okay, plus, so the A is 240 over 120 square. Sorry, ada. Okay, 240 over 120 square, and then R2 is 0.184. Okay, so you can find the value of R equivalent. So let me press the calculator. 240 divided by 120 square is 4 times 0.184. Okay, I think okay, I put the wrong number here. So this is 0.184 and this is 0.055. Maybe I will write back. Okay, R equivalent is equal to R1 plus A square R2. Okay, so the R1 is 0.184 plus A 240 over 120 square. The R2 is 0.055. Okay. Okay, so based on, I've just pressed the calculator and the answer is 0.404 ohm. Okay, so this is R equivalent. So back, we need to find the I1 first. Okay, so the I1, okay, is S over V1. Okay, which is 3K over 240. Okay, 3K 240. So 12.5 amp. 12.5 amp. the M is 12.5. So you can get the value of that of P copper is 12.5 square with the R equivalent is 0.404. Okay. Okay, so here the value is see that 63.125 watt. Okay, so the PCU here is 63.125 watt. Okay, so I think we have less space here. So back to the equation. So we can find the efficiency based on this formula. Okay, so the P out is a 3K over 3K plus 28 plus 63.125. Okay, so here you can get the answer 3K plus 28 plus 63.125. Okay, 3K. So you get value is 0.97. So the efficiency is 0.97. Okay, so I think this is the only question. Okay, I think the last two question is very important. It might be on your final, so be prepared on all questions. Okay, for your chapter 2 for transformer parts. Okay, thank you very much.